Hello, I'm Rashid Ben Moussa, Professor in Industrial Engineering at Qadi Iyad University in Marrakesh, Morocco. I'm pleased to present today this paper which seeks to compare the relevance of two pedagogical models for teaching and developing creativity, namely Massive Open Online Course, better known under the name of MOOC, and face-to-face course. The outline of this presentation is as follows. I present first the problematic which justifies the choice of this subject as well as the approach used to answer the research question. I then present the modalities of execution of the experiment by specifying the deployment rules of the two types of courses. I have to set out the analysis carried out on the observations obtained, and I summarize the results on this basis. Finally, I will discuss the main conclusions as well as the limitations of this experiment. I end by citing some perspectives to improve the next experiment. Teaching invention problem-solving methods is complex because it aims to improve the learner's creativity, which is not a knowledge but an intrinsic competence. This paper presents an empirical study to compare the effectiveness of the MOOCs model and the face-to-face model for teaching methods of solving invention problems. It answers the following research question. Is MOOCs model more relevant than face-to-face model for learners' creativity development? To answer this question, we have adopted an experimental approach which consists in observing a population of 28 students who followed a MOOC on solving invention problems. The MOOC covers the majority of 3 stools. The same population followed in parallel a face-to-face course on 2 chapters that the MOOC does not cover. The first chapter concerns the ASIT method, Advanced Systematic Inventive Thinking, for which we did not have the copyright required to its integration into the MOOC. The second chapter concerns the ARIES algorithm, too complex to be integrated into the MOOC as well. The objective of this experiment is to analyze the correlation between the results of this population for the 2 models of education. It was conducted for about 3 months between November 2019 and January 2020. The general objective of the MOOC is to provide registrants with the knowledge necessary to understand the concepts of innovation, creativity, and invention, as well as to gain insight into various tools known in this field for their ability to help solving invention problems. The content was divided in 6 weeks. Week 1, entitled Innovation, Concepts and Approaches, cover 3 introductory sections. The first one is what is innovation, creativity, invention. The second is problem solving, finding a solution. And the last section is characterization of problem solving methods. Week 2, entitled Recognizing the Problem, covers the 3 most used 3 tools to identify a problem: the multi-screen tool, the intensification tool, and the golden fish tool. Week 3, entitled Analyzing the Problem, covers different facets of the contradiction concept: technical contradiction, physical contradiction, and the system of contradictions. Week 4, entitled Synthesizing Solution Concept, presents inventive principles, separation principles, and standards. Week 5, entitled Realizing and Evaluating Solutions, cover 3 areas: resource mobilization, effect pointer, and evaluation and ranking. Finally, Week 6, entitled Inventive Resolution Scenarios, presents 2 resolution scenarios by principle and by ARIES, as well as final synthesis. Face-to-face training covers 2 chapters, ASIT and ARIES. The ASIT course covers the rule of the closed word and qualitative change, as well as the tools unification, multiplication, division, subtraction. The ARIES course covers mainly the first 3 steps of the algorithm: analyze the system, analyze the resources, and define the ideal final results and formulate the physical contradiction. The face-to-face course took place in a classic passive learning environment. The learning model was predominantly transmissive. The trainer, through PowerPoint presentation, delivered the content to the students. A series of tutorials is used to involve students in the training and to illustrate the content. However, the MOOC uses a more active learning environment. Students must watch 3 videos per week and carry out activities in the form of exercises, drag and drop, and multiple choice questions to assimilate the content. Through interaction and participation via forums dedicated to the theme of each week, students play an active role in the material and the course's delivery. The face-to-face course, lasting 4 hours per week, takes place in a classroom for 4 weeks. In class, the trainer sets the pace according to learners' audience and responsiveness. For the MOOC, the content of the week is launched every Wednesday. Exercises and multiple choice questions are open all the week until the following Wednesday. It's up to the student to define his own rhythm for the work that must be accomplished during the week using the MOOC. Students therefore have flexibility in determining where and at what time of the day they participate in the MOOC. For face-to-face course, the discussion takes place in the restrictive environment of a physical classroom. With MOOC, students have more opportunity to develop well thought out and researched responses to the discussion than that of the face-to-face class, which allows all the students of the course to contribute and draw conclusions together. For the face-to-face course, the examination on table is individual. It took place in the classroom according to the schedule established by the administration. Students were monitored during the exam period, which was limited to 3 hours. For the MOOC, self-assessment activities based on multiple choice questions and drag and drop exercises are submitted each week to students. The parameters chosen by the teaching team gave students the opportunity to choose the correct answers from a list of proposals and to check their answers twice before submitting their assignment. The final exam took up the content of all weeks. The final score was automatically calculated by the platform using the following scales: 30% for multiple choice questions, 30% for drag and drop exercises, and 40% for the final exam. Since the students are physically located in the same place at the same time, a face-to-face course is more convenient to group work. The tutorials were mainly conducted in class and in groups. Online courses also often include group work. Group work has not been used explicitly in this MOOC. The evaluation of the face-to-face teaching material was not carried out because its manual completion was tedious. Unlike face-to-face course, the evaluation of teaching materials is easy in a MOOC through an online questionnaire. The question asked to learners concerned quality of videos, sound, graphics, text, instructions of self-assessment, clarity and understandability of videos content, synchronization of videos content, convenience of self-assessment, references and forums to help better understanding the videos. The scale used to score the questions varied from 5, very good, to 1, very bad. As a reminder, the experience described in this paper consists in observing a population of 28 students who followed both the MOOC and the face-to-face course. Learners' evaluation gave rise to 8 types of grades, whose relation was analyzed by linear correlation. To do so, we used the 2 factors Bravett-Pearson coefficient. This coefficient is equal to 1 in the case where one of the variables is an increasing affine function of the other variable, to -1 in the case where a variable is an affine and decreasing function. The intermediate values provide information on the degree of linear dependence between the 2 variables. The closer the coefficient is to the extreme values -1 and 1, the stronger the linear correlation between the variables. A correlation equal to 0 means that the variables are not linearly correlated. They can nevertheless be correlated non-linearly. The fundamental principle of the analysis is based on the fact that the evaluation on table, since it's individual and supervised, reflects well the real competence acquired by the learner in terms of creativity. Analysis 1 seeks to calculate the correlation between the final grade of the MOOC, which includes the self-assessment and the final exam, and the evaluation on table grade covering the content of the face-to-face course and the content of week 1, 2, 3, and 4 from the MOOC. The interest of this analysis is to answer the question, does the MOOC generally reflect the level of competence acquired by the learner? Analysis 2 seeks to calculate the correlation between the grade concerning the multiple choice questions of the MOOC and the grade concerning the multiple choice question of the evaluation on table, which deals with the same content of MOOC multiple choice questions. It relates also to the drag and drop exercises in the same way. The interest of this double analysis is to answer respectively the questions, does the MOOC reflect the seriousness and the implication of the learner when replying to multiple choice questions, and the seriousness and the implication of the learner when replying to the drag and drop exercises. Analysis 3 finally seeks to calculate the correlation between the grade of the evaluation on table, which covers parts studied only on the MOOC, and the grade of the evaluation on table, which covers only the chapters studied face-to-face. The interest of this analysis is to answer respectively the questions, do the learners have a preference for training by MOOC compared to face-to-face training, and does training by MOOC give better results in general than face-to-face training? The analysis and the results are summarized in this table and show that the MOOC does not reflect the learner's level of acquired competence. The MOOC weakly reflects the seriousness and involvement of the learner when replying to multiple choice questions. The MOOC does not reflect the seriousness and involvement of the learner when replying to exercises. Those who appreciate face-to-face model do not necessarily appreciate the MOOC model, and vice versa, but the MOOC model gives slightly better results. This paper raises a general research question regarding the relevance of the distance education model via MOOC in comparison with the conventional face-to-face model. It more specifically addresses the relevance of this model for learners' creativity development through solving invention problems methods teaching. The experiment, which was conducted at the National School of Applied Science in Marrakesh, concerned 28 engineering students from the Industrial Engineering Department. Although it leaned slightly toward the MOOC model, the study did not provide a conclusive and definitive answer to our research question. Several reasons for this can be cited. The limited number of participants. Indeed, 28 students are not a significant population for MOOCs. The motivation of learners regarding the use of MOOCs. Almost all learners have never experienced distance learning through a MOOC. The rate of participation in discussion forums, consultation of additional resources, and the response to content assessment questionnaires clearly demonstrate this non-motivation. The students therefore had a kind of psychological inertia with regard to this new model, accentuated by their dependence on the classical face-to-face model. The quality of the content itself as well as its synchronization also seem contribute to this limit, according to the respondents. The full power of distance education has not really been harnessed. More specifically, group work tools in synchronous and asynchronous mode were not used to support learning explicitly. Beyond its success, this experiment allowed us to test the relevance of the methodology applied to compare face-to-face and MOOC teaching. As a perspective, several actions will be considered for the next experiment in order to counteract the limits mentioned above. Given the increase in enrollment in the industrial engineering department, at least 50 students will be able to participate in the experiment next year. The motivation of the learners will also be supported by several actions. Give open questions to discuss via forums, make explicit references to consult in learning activities to additional resources, require the filling of questionnaires through personalized monitoring of learners, and other actions. Improve the quality of the videos and their synchronization as well as the self-assessment instructions. Give mini projects to be realized by groups of 4 to 6 learners using the synchronous and asynchronous collaboration tools, and maybe other actions. Thank you for your attention.